All right, good morning, everyone. Can you hear us? Great, and welcome to reInvent. We are so happy that you chose this to kick off your session and week here at Vegas. So welcome to What's New with AWS Backup. My name is Bisman Sethi, and I am a senior product manager with the AWS Backup team. I'm joined here with...
Hello, everybody. I hope you all can hear me well. My name is Sabit Venkatajalpati. I'm a worldwide solutions architect, part of the AWS Backup team, and I have the privilege of working with customers worldwide, onboarding their data protection strategies to AWS Backup in a cost-effective and secure way. Welcome again.
And we are joined here with two of our great customers, Fahim Larrick from Freddie Mac and Alex McKechnie from Skyscanner. So before we get into it, we have a really nice packed room for 9 a.m., but would love to hear who here is familiar with AWS Backup, uses our service or products. Okay, that's great. We'd love to hear that, and hopefully by the end of this, we'll have converted a few more customers. But today, we really want to go through a bit of a journey on what AWS Backup is and why it's such an important tool. We'll talk through some of our more recent launches, what we hear from you, the customers, and what we believe is required for your best data protection journeys. And then most importantly, I'll hand it over to our important customer speakers to talk through how they're using our product today, how it's helping them meet their data protection goals. So with that, starting off a little bit of why we're here. We know that data is growing at an exponential scale, fueling AI, LLMs, also your business-critical applications. And we know that companies and customers alike need a tool to make sure that their data is protected, and they also have governance and compliance over it. Gone are talking about terabytes and petabytes, and we are at the exabyte scale. And how we know that this is such an important piece is, to date, we have over 140,000 customers protecting their data with us. And that means they're protecting over 2.9 exabytes worth of data. I'll let that sink in, but that is a massive amount of data, and we see that to continue to grow as years come on. And while we talk about 140,000 customers, it's not just the top 100 customers. It's also the smaller customers, the startups that are getting into their data protection journey, just talking about how absolutely critical the services we have are today. Now, Sabith, I know you talk through architecture with our customers every day, but how are you seeing customers actually implement this solution?
Yeah. Thank you, Bisman. Now that you're seeing the scale at which AWS Backup does data protection for our customers, let's primarily take a step back and then understand the three different models that you have seen in the backup space. So we got started with a strategy of backing up your enterprise data center data using software provided by backup vendors onto backup appliances residing in your on-premises setup. That's how it all started. But with the onset of cloud, things got a little bit of shift, and we have seen a hybrid model kicking in which data that is primarily residing in a corporate on-premises data center kind of get backed up into cloud as a way of securing and having a second copy of data. But with more and more cloud-native ways of doing application architectures and all those things, there's more workloads natively running in AWS. That's when the third model kind of kicks in, and where we mentioned that each and every service that you have in AWS has to provide a way of backing up your data to cater to all of your disaster resiliency requirements. And that's where the prominence of AWS Backup comes in. So what is AWS Backup? AWS Backup, in simple terms, is a policy-driven service that allows you to work backwards from your data protection requirements. That's the more critical thing. Once you have identified your data protection requirements or strategies, you kind of work backwards from it and then define policies within AWS Backup, and AWS Backup does the heavy lifting for you. Wherein every service that is supported by AWS Backup today, you will be able to do a single kind of policy to have them backed up. And this goes into the different strategies of backup, where you define how often to backup, where to backup, how many copies, what's the life cycle, and all those things. But that's all simplified within AWS Backup. Let's probably go deeper into this one and understand a few different use cases that AWS Backup kind of does well. The first and foremost thing is obviously the one that we talked about as the third model previously, which is cloud-native backups. So in the cloud-native backups, instead of you having to go into individual services that you have protection data running to define data protection strategies, AWS Backup kind of does the undifferentiated heavy lifting for you. So that's the cloud native backup space of it. And then you might be running workloads in most regulated industries like the healthcare or financial service industry. And then if you have to cater to regulations like DORA or NYDFS and all those things, you probably can actually work backwards from your regulatory requirements, define data protection strategies within AWS Backup, and have AWS Backup not just define, do the backups, but also provide you with reports that you could hand over to your internal or external auditors. And the third pillar, which is kind of getting which is the more important aspect of it, is the disaster recovery aspect of it. How much ever resilient your systems are, you have to be planning for failure. So the disaster might kick in different aspects of it. The operational recovery aspect of your disaster will be covered in the cloud native backups that we saw in the first pillar. But if you're talking about like being resilient against regional failures and all those things, you probably will have to come up with a strategy of doing multi-region backup. So that's the third pillar, which is the disaster recovery aspect of it. But now, a fourth pillar, which is quite prominent these days, is the cyber resiliency aspect of it, wherein you want to be protecting against not just internal and external threats. You would also be wanting to be ensuring there is lesser business downtime and more business continuity in place. And this is the ransomware recovery aspect of it, where you have capabilities within AWS to ensure your backups are indeed always secure and available and clean in nature. What are we doing in this space within the cyber resiliency aspect, which is the fourth pillar that we just kind of looked at? AWS Backup recently announced the general availability of what we call the logically air-gapped vault, which is a new type of AWS Backup vault. And in simple terms, a backup vault allows you to logically group all of your backups so that you can manage and maintain them as a single entity based on your data classification requirements. So we made two major changes to the vault concept. One is that the immutability aspect of AWS Backup Vault, which was a choice given to customers previously, is now no more a choice. You have to lock them in compliance mode by default when you create the logically air-gapped vault. Primarily because attackers kind of go behind your backups to drop them, which is your last mile of defense. The second thing that we kind of brought in as a change was the introduction of what we call the AWS Backup Service Own Key. So previously, customer managed keys were a single point of failure. And now with this service owning the keys, there's no more a threat vector of your keys being deleted by malicious users with malicious intent. With the two different changes, we also kind of simplify the entire restore and validation experiences. This is done by the seamless integration of AWS Backup Logically Air-Gapped Vault with AWS Resource Access Manager. Now you would be able to share contents of a Logically Air-Gapped Vault with any other account of your choice, not just within your same AWS organization, but also a different account in another AWS organization. And you can get into the details of it, like there's a different session happening tomorrow where we go deeper into this one with demo. That's not just it. Like, we kind of talked about how securing your recovery points will be done using Logically Air-Gapped Vault. A prime requirement by almost all of the regulators across the globe has been on how do you ensure you're not just taking backups, you're not just protecting your backups, but you're ensuring the backups are indeed clean and recoverable when there is a disaster or a need to recover. So AWS Backup announced the general availability of restore testing last year. With restore testing capability, much like how you define backup plans, you can define restore testing plans to work backwards from your testing strategies. So in this one, you kind of say, okay, test the recovery points every week and ensure there is actually restorability being validated. Not just validating the restorability, but you also have the option of ensuring this can integrate with third-party providers to validate the contents of your backups so that you can perform things like ransomware scanning, malware scanning, or even database validations using a simple Lambda function and all those things. So that's all simplified with AWS Backup. But the AWS Backup PM and engineering team have been very busy this year building amazing capabilities for our end users. Let's hear it from Bisman as to what they are.
Thanks, Sabith. So Sabith just highlighted two of our key launches in the past year, specifically around that ransomware protection pillar. That being said, we know backups address many use cases, and we want to make sure our capabilities are continuously being improved across our cloud-native backups, ransomware protection, and moreover, our platform improvements. For example, we recently launched an improvement for S3 backups, where you can now restore all versions versus just the last, which was a big customer ask. as well as expanded capabilities for our cross-region, cross-account backups for certain resource types, as well as enhancements to the AWS Backup Calculator, as we know cost is top of mind as customers try to adopt this at scale. So happy to talk through any of these after the session if there's any questions. But with that being said, Sabbath and I can talk all day about how wonderful AWS Backup is and the capabilities that we know it provides. However, our customers here live this every day, and so I'd like to invite Fahim Larik from Freddie Mac on the stage to talk through his journey.
Thank you, Bisman. My name is Fahim Larik. I'm part of the platform and infrastructure team at Freddie Mac, and in today's session, I'll go over how we enhance our data protection strategy using AWS Backup. I've broken down my presentation into 3 main sections. I'll go over the key drivers for why we implemented AWS Backup. I'll give you a quick solution overview, and then I'll complete my presentation by giving you some of the lessons learned as part of our adoption. And I hope that you find that useful. But before I go into my main topic of discussion, let me give you a quick overview of what Freddie Mac is for those of you who do not know much about Freddie Mac or do not know what we do. So our mission at Freddie Mac is to provide liquidity, stability, and affordability to U.S. housing market. We operate in a secondary mortgage market. What that essentially means is we don't offer loans directly to the customers. We purchase loans from the lenders, securitize them, and sell them to the capital markets. And in return, the money received by the lenders, they are able to provide more loans to the more homeowners and the borrowers. We operate in 2 business segments, single family and multifamily, and supported by our capital markets division. In support of our customers, we provide a bunch of tools, technologies, programs, and services as well. And lastly, for general public, for education, we do a lot of resources and tools for the homeowners themselves. Okay. With that said, let me come back to my main topic of discussion. So let me begin by highlighting some of the key areas we identified for improvement in terms of our data protection strategy. 6 years ago, when we started our journey on AWS, we were trying to do application and infrastructure modernization. Our first iteration of the backup approach was to use the native tooling provided by AWS to back up individual AWS services. While we were able to protect our data quite well with the tooling that we had, what we soon realized as our adoption increased, the scale increased, we realized that we needed a more centralized management of this capability. So that's when the AWS Backup came into our selection process. In addition to the centralized approach of managing the backup, we also looked at the industry. Bisman talked about it. Sibat talked about some of the ransomware and other kind of malware threats have been more sophisticated in the industry now. So as these things evolve, our security and operational resiliency team continue to update their directives and requirements for us to implement. So for that, we had some additional requirements to meet as well, which included our immutable copy of the backup data, and we also needed to have a cross-region copy of the backup data. Lastly, another key driver was we are, at Freddie Mac, we have multiple infrastructure development teams. And as I mentioned, in a decentralized approach, they all had their own kind of way of doing the native, use the native tooling to do the backup of their services. With this centralized approach, we wanted to make sure our policies are enforced consistently and adopted by all these various infrastructure development teams. Okay. So these were some of the key drivers. To address each of these focus areas, we set ourselves a set of objectives. Number 1, we wanted to ensure we have centralized management capability. I already talked about it, but to ensure that we have enforcement mechanism and monitoring mechanism through this capability. Number 2, we wanted to also reduce our recovery time objective. so we wanted to make sure that we are backing up the data fast and being able to recover the data faster as well for our operational backup needs specifically. We needed to ensure we have a copy of the backup that remains intact and unaltered in case a source data is compromised. This is where the immutability of the data comes in. Additionally, we wanted to make while the local backup for operational needs, we had one goal. In addition, we needed to also have a cross-region copy of the backup. And then we wanted to make sure that the heavy lifting of the actual backup service is taken on by the vendor itself. So we don't invest time in terms of our actual management and build out of the service. We wanted to use our engineering capital in terms of our adoption and enablement. And then, as I mentioned, consistent backup policy and sustainability was another key objective for us. Sustainability really means that we are applying the policies consistently, monitoring the policy, and reacting to any anomalies as they come in with some certain level of controls. Okay? Now let me get into the high-level solution overview. What you see in this diagram is a logical architecture view on how we integrated AWS Backup within our environment. On the top, you see management accounts. This is the place where we are basically enabling the policies, enforcing the policies, and then monitoring the ongoing compliance with the policy. Audit manager here is a key component of a solution that we use to monitor the statuses of the backup. The second section underneath that depicts the resource types that we are using, where we have data assets. And then in that particular region where these resources are, we have established a local backup vault. That allows us to do the local backups quickly and be able to recover that backup as well. This is the actual, which gives us the reduced recovery time objective here for this particular capability. To meet our requirement for immutability of the backup, we implemented a cross-region, logically air-gapped vault with compliance lock. So with that, basically those are the key components of the AWS Backup. In addition to that, what we had done at Freddie Mac is a concept of a clean room. What this basically is no different than any other AWS account, but it's used for different purpose, and that is for our application teams and data, application owners, data owners, to validate the data in a clean room, in an isolated environment, before we are able to restore them in the target destination. This is an interim, optional step for them, but it gives the assurances to our application owners that they are able to see the data recovered from the vault before it's actually released to the real, environment where the application is. So this was our, one of the key features that we built for our own implementation. In a nutshell, this is an overall solution, components that we built. But I'll be remiss if I don't mention a few other things. One of the things, while we designed how our various components work together from AWS Backup, most of the heavy lifting is done by AWS. They designed for scale, performance, availability, and data integrity assurances, which helped us a lot because we didn't have to design for all those components as we were implementing AWS Backup. Additionally, we had to also implement some of the cost optimization at the source as well. So when we realized, obviously, AWS Backup is making a copy of the data, and then you have an immutable copy. So there's cost consideration there. What we looked at is the source where the AWS resources are. And some of the things surfaced during that process that we were not using S3 lifecycle policy, so we implemented S3 lifecycle policy to reduce the non-current versions and things that you don't need. We implemented exclusion process as well, So, not all data needs to go to the vault because of some of the ephemeral nature of the services that we run. And some of the persistent data needed to be there. So those are a few additional things that we did to control our cost. Lastly, I'll talk about, let me actually get to the next slide, and I'll talk about a couple of additional things. So before I wrap up my presentation, I put together, as part of the solution, as we adopted this AWS Backup into our environment, there were a bunch of lessons learned. And I would like to share some of those things with you all, so you may find some of these useful for your implementation. Number one is the tag-based inclusion of resources. Use of tags simplified our backup adoption process. It is as simple as including or excluding a particular resource in your backup system by using a particular tag. However, the key point of, while the implementation is quite transparent to the end users and application owners, you needed to know what to exclude, what to include, and we had to develop a process around it. So you may need to look at, your data at the source to see what makes sense, and what process you need to, set up for it. I mentioned about the cost optimization and some of the things I already referred to from S3 lifecycle policy, exclusion of non-persistent data. The other thing that AWS already provides is a continuous backup. It started with the periodic backup and then started to move towards the continuous backup that helps also not only from the recovery point perspective, but also from a cost optimization standpoint as well. The other thing that we were not thinking about was the delete markers that exist on S3. So we had to remove, look at the delete markers that were also adding to the cost. But my favorite one is really the validated recovery process. I cannot reemphasize, enough on this point that while we are using a managed service, AWS Backup provides us the restore capability. When you really look at your infrastructure, there's ephemeral resources, there's cloud-native applications. And so when you talk about the end-to-end recovery process of your infrastructure, which is infrastructure as code, how do you recover end-to-end using AWS Backup? So we had to do a lot of testing to prove that we can recover not only our data assets, but also our applications in all. And that exercise proved to be highly valuable because we learned a lot from updating our playbooks as we were implementing the recovery processes. Now, the next one is monitoring and automation. This is another area that we focused a lot on. Not only do we use the AWS Audit Manager, but as we find some anomalies through an Audit Manager, we build some additional automation to integrate with our incident management process that we use internally, and that allows us to correct any anomalies that come in very quickly and effectively. So we had to put in some control automation. The core is from a monitoring standpoint is Audit Manager, but we complemented that with some of the additional automation we built for our own integrations with our incident management processes. That helped us a lot, from correcting any anomalies that we see. Last but not the least, the training for platform engineers and developers. As I mentioned from at the beginning, we have multiple infrastructure development team in a decentralized, manner. So our goal was to ensure, while we were centralizing the backup capability itself, how do we ensure that the enforcement and adoption is consistent across all various teams? And so, as I mentioned, the solution itself is pretty straightforward, inclusion, exclusion, but understanding where you really want to, focus on from, your understanding your resources that you're managing and how you manage your ephemeral resources and how you use the backup solution for your ephemeral infrastructure. Like we use Kubernetes clusters quite a lot. Our worker nodes are ephemeral. So how you back up that versus a pet type of infrastructure, which is always there. So those are the kinds of areas that we focused on for them to understand. Unlike traditional backup systems that people have used in on-premises, here we have a lot of infrastructure as code kind of components and how you think about not only the data assets, but that's given, your S3s, your databases, and others, but it's also the infrastructure as code that we focused on and people to understand how to use the recovery processes supporting that. With that, we are not done yet. Savit mentioned the capabilities, restore testing. We are continuing to implement and testing that process that we will save some time in our recovery validation exercises that we are doing, so help use that automated restore testing. And then we are continuing to complete the transition to the continuous backup for all our resources. So with that said, thank you everyone for your time, and I'll pass it back to Bisman for the rest of the presentation.
Thank you so much, Fahim. I know it's so great to hear how customers are using AWS Backup and going through that journey of making sure you're cleaning up the right resources and right-sizing the product for your own fit, and making sure all your compliance requirements are met. So I'm going to pass it over to Alex, who also has a riveting journey with Backup, but very different from him. So off to you.
Senior software engineer at Skyscanner in Glasgow in sunny Scotland. So I work across the production platform and the security tribes at the moment, and today I'm going to talk through Skyscanner's journey over the past couple of years with AWS Backup. So first of all, who are Skyscanner? We are a global leader in travel, helping travelers plan and book their trips with ease and confidence. We have over 110 million monthly users spanning 180 countries, 33 languages, and we're connecting them to over 1,200 flights, hotel, and car hire partners every single month. For these travelers, we are simplifying the complexity of travel by searching over 80 billion prices every single day. So for anything flights, hotels, or car hire related, please go and check us out. So let's take it right back to the beginning. What problem are we actually trying to solve? So a couple of years ago, a substantial amount of data that is essential to running our production systems was not safeguarded against potential data loss events. Specifically, we're talking about operational data here. Now, as a company powered by data, this was a significant problem for us. There were quite a few challenges in the way to actually overcoming this as well. First was discovery. We lacked a complete and comprehensive understanding of all data stores that existed in all accounts in our organization. Secondly was ownership. The majority of data stores did actually have owners, but there was a small subset that didn't, and this was something, again, that we had to solve. Third was criticality. Was data actually being used to serve production traffic? Was it being held for moving purposes? Was it simply not being used at all? Those were all things that we had to cover. And then, lastly, was backups. Only a small subset of this data was actually backed up using a range of inconsistent tooling across the organization. So let's take those first three problems on their own. As a platform and security function, we had this clear initial objective. We have to understand what operational data we have, who owns it, and if it's critical for our operations. So understanding what data we have is a relatively simple problem. We simply extended our existing inventory tooling to cover more accounts, more regions, and more AWS services. The ownership problem that I mentioned before, our security teams did an absolutely fantastic job going all across the organization trying to find who owned these unowned data stores and getting that ownership attributed. And then lastly was criticality. This is where we ran into some problems. So we started asking service teams, but also people within our own teams, if their data was critical or not. And we noticed that people's response was based on their own definition of what the word critical actually means. And it turns out that that is completely different for anyone that you ask. So we started to put in place a standard definition of what we define as critical. And you can see that on the right-hand side here. So service owners, we would essentially say to service owners to assume that their data was completely lost. And if the business was to move forward without that data, would there be significant business impact? Behind this phrase, significant business impact, were a series of business metrics and service classifications that aren't included here. But if a service owner could say no to that, It wasn't actually required that they had to back up their data. Their data was non-critical. But if they could say yes, then we had to ask a follow-up question. Can the data be recreated? So if the data can't be recreated, and it's going to cause significant business impact if we lose it, then that's 100% something that we need to back up and we need to onboard. However, if it can be recreated, then there's a bit more nuance here. How long does it actually take to recreate that data? What is the impact during the time where we're actually recreating that data to the business and to the product? And lastly, how much does it actually cost to back up that data? So there was a lot more nuance here. There was a lot more conversations and trade-offs made at this point. In parallel, our platform teams were working on building a centralized backup solution that could sit within our AWS organization and serve every single AWS account that we have. And this had AWS Backup at the core of it. So you can see on the left-hand side here, we have source accounts, just workload accounts that run actual service workloads. For service owners here, we use the tag-based resource selection within AWS Backup to allow service owners to simply tag their data store and have that onboarded directly into a source vault within the same account. Ignoring this intermediate vault for now, we copy then cross-account into a central backup account, and we copy across a region and an account boundary here. All vaults within this account have AWS Backup Vault Lock enabled, so we get the full features of immutability here. So on one side, we have incredibly low friction onboarding for service owners, but on the other, we have complete immutability of data. So this was a really, really nice place to be. Now, let's cover this intermediate vault. This is Sabbath's favorite topic. We put this intermediate vault in place to solve a range of encryption problems that we actually found here. So there are some services within AWS Backup that do not support independent encryption. These are things like EBS and RDS. When you actually take a backup of them and you get a recovery point within the source vault in the source account, it's not re-encrypted as part of that process. Now, this is normally OK, but if you've got resources that are encrypted with Amazon-managed KMS keys, this gives you a problem. When you back up those resources, the recovery points are then encrypted with Amazon-managed KMS keys. And with the inherent nature of those keys, they can't be shared cross-account. So you have a problem. You can't share the recovery point cross-account either. So you need this intermediate step in the middle. This intermediate vault uses a customer-managed key. And when we copy to the intermediate vault within the same account, we perform a re-encryption operation there, which then allows us to copy directly over into the central backup account here. So with an understanding of our data and the capability to actually back it up with really, really low friction, we essentially could open the floodgates here and allow service owners to actually onboard. This was performed through a range of communications across the organization and also documentation that we put together on why this was important and actually how to onboard to AWS Backup. But more formally, we tracked this all through our operational excellence process. We have a tool internally that allows us to effectively run assertions over CloudFormation templates. So we can ask the question, for all of the critical data stores that we have, are they all being backed up? And if you, as a service owner, are failing on that particular check, that will report up into your PRs. So you'll see it every time you raise a pull request. But secondly, that also reports up into our operational excellence process, which is reviewed every single week as well. So with all of this and collaboration with service owners, we're now happy to say that we're at the point where we have 100% of our operationally critical data onboarded to AWS Backup. And this is where the real business wins actually come in. Now, what did we learn? Will this work? What did we learn as part of this process? The first learning that we had is that not all data stores have the same backup requirements. Initially, to simplify things, we made an assumption that we could impose a daily frequency of backups and a set retention period, and this would work for every single service owner. Unfortunately, we were wrong here. Service owners were coming to us with particularly large data stores, and they were saying that they wanted to have lower frequency backups to support their needs and to have lower costs here. But on the other side as well, for service owners with data stores that were changing more and more frequently and had shorter recovery point objectives, they could also benefit from having higher frequency backups here. So we wanted to find a way that service owners could effectively easily define backup plans that suit them to their exact needs. Secondly, low friction onboarding is not always positive. So as part of this process, we accidentally onboarded a 900 terabyte S3 bucket onto AWS Backup. And when we seen the cost the following day, we were quickly running around trying to find all the recovery points and delete them so that we didn't incur that cost on the following day. Thankfully, and I cannot emphasize this enough, thankfully, this was before we enabled Vault Lock, so we could actually solve this problem. So these were two things we wanted to solve. We use AWS CDK to define a lot of our core infrastructure at Skyscanner. And this means that our backup infrastructure is actually built just through a simple Python CDK application. What we decided to do here was effectively build a model within that Python application that represents what a Skyscanner-specific backup plan looks like. And you can see that on the screen here. So a backup plan has a name, it has a list of rules, each of which have cron expression periods. It has tags that it targets by, and it has resources that it targets by. And this simplifies things massively, so developers can effectively come along and just define exactly what backup plan they want and need here. Behind the scenes, AWS CDK takes care of all of the heavy lifting of actually building out the resources, so backup plans, resource assignments, copy jobs, and all of the encryption complexities that I showed before into CloudFormation templates that can then be deployed across our organization here. Also, as an added benefit here, we decided to add this exclusions list. So there were a couple of large petabyte scale S3 buckets in our organization that we knew we never wanted to onboard to AWS Backup due to the nature of those buckets and the criticality there. So what we decided to do is to put a safeguard in place so that even if a service owner did try to onboard one of those buckets, it wouldn't work. And you can see that here. We just have this list of exclusions at the bottom. Now, lastly, I've talked a lot about backups. I'm now going to cover how we're thinking about restores. So Skyscanner are thinking about restores in a slightly different way to normal. In any sort of traditional backup mechanism, the common workflow for any restore operation is to go and find the backup that you want, call some restore API, and you get a resource up and running that you can then use in your environment. However, when everything is defined in a world where everything is defined as infrastructure as code, everything is checked into version control, and we run everything through continuous integration and deployment, this poses some problems. How do you then backport those changes into all of those tools? So we started to think, can we allow service owners to perform a restore operation the exact same way that they perform any other change to their application? And it turns out we can actually do this. So let's take this example. Let's say a service owner writes a CloudFormation template that has an EC2 instance and an EBS volume within it. They check that into their version control system, they raise a pull request, they get it approved, they merge it, it runs through continuous integration and deployment, and is deployed out as a CloudFormation template into the AWS account that they have. And behind that stack is an EC2 instance and an EBS volume. Now, the data in that volume is changing continuously all the time, and AWS Backup is taking recovery points of that data store every single day. Now, what happens if we lose this stack completely? What do we do? Now, there was a key insight here that made this a lot easier for us. EBS recovery points are actually backed by real EBS snapshots that you can see in the account, and you can go grab the ID. So we thought, if we couple this with the ability to provide a snapshot ID when you create an EBS volume within a CloudFormation template, then we could massively simplify restores here. So we gave this a shot. We simply took the snapshot ID of that of the latest backup, added it as the snapshot ID parameter in the EBS resource within the CloudFormation template, checked that into our version control system, raised the pull request again, got that approved, got it merged, runs through CI and CD, and it's deployed out into the target AWS account. At that point, we have a stack with exactly the same configuration before and the same state as that of the previous backup. And as a result, we started using this as the normal way to restore in our organization. And it means that developers can just use the same tools that they know and love, even in a restore scenario. They don't need to do anything different. They can simply just raise a pull request, as they always do, for making changes to their application if they need to restore as well. So this significantly lowered the restore friction and the cognitive overhead of performing restores. Now, what's next for Skyscanner with AWS Backup? So as I mentioned, we are heavily down the path of restores at the moment. We have actually put a production standard in place now that is mandating that service owners are performing restore operations on a regular cadence here. And as a result, we're getting loads and loads of feedback from developers here to understand how we can lower the frequency, how we can make restores a lot easier for service owners. Specifically, logically air-gap vaults are going to massively help us here, particularly for cross-account restores. So for cross-account restores, we currently have to actually run copy jobs to copy the recovery points across accounts. But as Sabbath mentioned, instead, with lag vaults, we can simply just share resources with Resource Access Manager, which is so much simpler and saves us a lot of time here. So yeah, as I mentioned, we're just continuously trying to streamline this restore process as much as possible. So that's our full journey, all the way through from problem statement to being 100% onboarded to AWS Backup now. So I just want to say a big thank you to Sabbath and Bisman and the rest of the AWS Backup team for helping us through this process. It's been awesome to work with them, and we're in a really, really nice place now. Of course, thank you all for listening, and with that, I will hand back to Bisman.
Thank you so much, Alex. It's great to hear what you and Fahim are both doing with the platform, both using it in different ways, but making sure all of your requirements are met, from engineering-led restores to clean rooms to looking at that air-gap solution. So just as some key takeaways before we get into the Q&A portion of the session, we really want to drive home why customers are using AWS Backup. As Sabbath alluded to originally, there are plenty of use cases. Customers want to use this at scale for ease of adoption, but they also need it for disaster recovery, ransomware, and compliance. And I think Alex, Fahim, you talked about great ways that that's exactly how you're using your platform. But overall, we want to make it sure that our platform is really there for centralization of data protection, the efficiency both of compliance and deployment, and that lastly, that ransomware protection platform where we're continuing to invest in features there, as well as seeing our customers use the platform in the way that would help meet them. With that being said, it's early on in the week, so there are plenty of other sessions coming up. I'll leave this up while we're doing Q&A so you can take a look, but we'll be having more sessions where we are deep diving into some of these topics, either resource specific, ransomware, as well as some code talks and chalk talks where you can get hands-on help with people like Sabbath and other engineers on our team. So we really love talking to you. We're here all week, so it's great. Please come find me, the service team, Fahim and Lyric. Alex will also be here. But we want to hear from you. We want to hear where AWS Backup is helping you, where we can be continuously improving, and how you're also using the platform. Thank you so much to our customer speakers.
Thank you.